Graham and I, we've been working in this space for probably 10 or 11 years now, and for the last all of those 10 years, every month I've been putting out a summation of what the models are saying for Victoria. So I've been looking at models and their outputs for some time. First of all, just a little sort of assessment, explanation of what a computer climate model is. It's a mathematical representation of what the physics says is going on around the world, but it's of a really coarse resolution. So here's the ocean surface in here. You've got a square in there, and there's mathematical numbers going on to describe that ocean for that whole box of about a 250 kilometre square. And above that square of ocean, you've then got a heap of stuff going underneath that. So lots of layers of boxes with mathematics describing them underneath. And then above the land, you've got, you'll have the land surface with mountains and stuff like that in it. And then above that, you've got lots of layers of the atmosphere showing how high that's going up. And all those things are, working with the laws of physics. Hot air rises, warm air holds more moisture. There's salinity, there's currents, there's winds, all those things going on. But the resolution is pretty coarse. Now, what's interesting is that our computing power keeps getting better, and so resolution keeps getting smaller. And if anything, though, our ability to initialise these models is better than we've got of mathematically representing them in the model itself. So once every 2 or 3 days, we have data coming in from all these floating Argo buoys. Once a week they come to the surface and tell us what's going on underneath them. Satellites zipping over daily, giving us information as well. Permanent buoys situated all through the Pacific, going up and down every day to the bottom and telling us what's going on in their little patch of the world with a wind finder and temperature to depth. And then, the people that are taking your reverse ships from WA and loading wheat back to Saudi Arabia or something, give them a few bucks on that ship to take the temperature, and they'll do that because they're bored out of their mind. And we've got fantastic information along the shipping lines of the world about temperatures. So you add all this stuff together, that then has the ability to initialise the model, but the resolution of this information is much better than the model's actually capable of currently doing. So let's have a look at some models here. This is the Bureau's POAMA model. That's the current model. On the other side, we've got what we're moving to in the next, this year, we would hope. And this is the UK Met Office's model. The current Bureau model, POAMA, works on a 250 kilometre square grid, so really coarse resolution. And the new big supercomputer is now going to be capable of working at a 60 kilometre resolution. So what I propose to you there is that on the current model here, things are saying they're a bit wetter here around Sydney. But if you sort of said, how about up around Ballina or something, can you make a big difference between what's happening here to up here? There's a slightly, I think there was supposed to be a slightly wetter section here around Albany. But could you actually say that that's going to be wetter than Esperance out here? And so this is the question about we're saying, is take a step away back from the model, cross your eyes, wait for the sort of 3D puzzle to happen, and go with the vibe of what it's saying, because the resolution of this thing is so coarse that you can't make really close distinctions between properties. However, when we get to a 60K resolution, we have a much better ability to do that. In fact, on a 250K resolution, you can't see the Great Dividing Range. There's not enough actual resolution in that model to see that. On a 60 kilometre one, you can. And I'm not sure, hopefully the picture's good enough. You can see a rain shadow effect down the Great Divide there from this prediction. The other thing that's most certain, or not certain, is critical, is to know the climate drivers in your area and how they affect the rainfall and at what time of the year. Because that varies around Australia, and models are much more believable when they're producing, they're putting out forecasts, and they're forecasting things that are capable of happening at the time that affects your rainfall. It just gives you a lot more confidence. So here's something, this is for central Victoria here, around Bendigo. the ticks in the boxes show when these particular climate drivers have the greatest correlation with rainfall. And fortunately, that's through most of our growing season, from May through to October. We've got southern annular mode doing a little funny flip thing in summer. But what people and farmers are always saying, well, what the heck's going on there in summer and particularly in autumn? And it's what we call the dreaded autumn predictability barrier, where predictability at this time is never good, and it doesn't matter what the model is in the world, it's never as good here as it is over here. So take least notice of models when they're making predictions at a time where those particular climate drivers don't affect your rainfall, or if they do, it's very hard to tell it from a year where they're doing nothing. So, is your model reputable? Now, I've never put this slide up before, but I reckon it's pretty cool because is the person putting out the model information, do they come from someone who's actually capable of doing this sort of stuff? This is 50 petaflops a second or something, Cray supercomputer. This is the whole 486. The person using this has no hope of doing the stuff like this on this resolution. And only a massive computer like this is capable of doing it at 60k resolution, which you might say is not good enough either, but that's just our lot in life, and that will slowly get better. So does the computer publish skill information, or the model agency? Do they produce information where they've tested their model over time and they can tell you, we know where it's good and we know where it's poor, and it's better at these times of the year than others, as opposed to not telling you that information at all? Does it provide hindcasts? Does it give you information to show how that model's worked in the past? And you can go and have a look at WET 2010 and going, did this model even predict that? Oh, look, it did. Or, gee, it didn't. Gee, it's a bit strange. Everything else was. And really critical is the best thing about some models is they provide some commentary about the model says this, we think that's really strange, we think this is going on, X, Y, Z, as opposed to, there's your map, suck it and see it, and stiff bickies. So which gets us to the concept of skill, and what I'm going to do now is present a heap of information from a number of different models, how they present skill of their model. So these are some skill models from the Bureau of Meteorology's POAMA model, just for Australia. I don't think we've got one person sitting from the overseas section over there, so we've left them out of this, unfortunately. But what you've got there is the skill of POAMA's model at varying times of the year, at summer, autumn, winter and spring, and the skill ranking from low, medium's not bad, high's pretty good. And what you can see is if you've got any kind of eyesight at all, and even Graham with red-green colourblind can pick this up, that unless you live in Rockhampton, nowhere in Australia has high skill at any time of the year for this model. And you can probably pick some areas, like not that anyone's really farming above the Great Australian Bight, but you can see the model never has any skill in some of those areas there. So when you look at a forecast, it's critical to look at this information to show, should I be taking more notice of what's going on here, or is this at a time where they're not usually very good and it's interesting what they're saying, but I'll just kind of put that to the side of it. Here's a different way of presenting skill. This is from the ECMWF in the UK. The first thing for the South Australians and the Victorians and the Tasmanians and the New Zealanders in the room is they're going, what's happened? Where's the rest of the world? And so what this model's does is it believes it doesn't have very good skill for predicting in these lower latitudes, so it chooses not to show you it. You can't even see the prediction. If you're from the Bureau of Meteorology, you can, but you're not allowed to tell anybody else. The other thing they have in this thing is this kind of statistical test. I've got no idea what this is, and so that's always hard to make comparisons when they don't tell you how they're actually doing their stats. But when an area is shaded in, they're saying there's a 10% something, that's good. And when you get a line that's bordering the shading, that's telling that there's a 1% level of some sort of skill. So when you're inside the boundary borders, that's clearly better than just being shaded. But that's the way this model chooses to represent whether there's any skill in the prediction that they're making. Here's another one. Here's the UK Met Office, and they use a thing called a ROC score. And basically, anything above a half is good, anything below a half is useless. So the grey colours are useless, the orange and red colours are really good. So when you're assessing the skill on this model, more orange for that time of the year, the more skill. Here's a model from the US. And it uses a different thing. It uses anomaly correlation, which Andrew was telling me is a pretty poor way of doing skill, so take that in mind. But a correlation, anything above 60% is not bad. So looking at this model's output, you can see some pink and dark green in a few areas, but the skill there is not exciting over much of the world. Which brings us to now looking at models and how they represent rainfall. There's two ways models do this, probabilistically and deterministically. The probabilistic ones are the ones we're used to seeing from the Bureau of Meteorology, and we see this one, the old chance of the rainfall being above median, a probability of above median. And as Graham was showing before, when they're saying there's a 30 to 40% chance of it being above the median, that's really saying that there's a 70% chance that the rainfall is going to be less than the median being close to the average. And so what that is saying is there's a greater probability of it being drier, but what that output there does not say, it will be dry. It's not an emphatic thing like that, it's couching things in terms of probability. The next way you do it, same data, same time. This is called a tercile distribution. Tercile means 3, and you've divided the data up into dry, an average third, and a wet third, and you're getting a probability of where it's going to fall in between that. So giving you more information than just above and below the median, but still, once again, couching things in terms of probability and not giving you anything absolutely definitive. Here's another way that the ECMWF does probability, and they've got their, you can see there, a 50-60% chance. So they're just, it's more similar to those other ones. Yeah, this is a tercile one as well. So you've got a chance of being drier. If it's white, you're sitting on the fence, and if it's green, it's predicted to be wetter, but there's also the opposing probability of being dry as well. Then we get to the deterministic ones, and everyone loves these because these will nail their flag to the mast and go, I think it's going to be dry. But it's very easy to take these wrongly as well, once because of that resolution issue. The other thing you've got here is that the scales of these things vary. So this is a model for 3 months, a modelled output for 3 months for winter, and the scale here you can see is in 0.06 of a millimetre per day, negative 1.5 millimetres per day. You've got to multiply that by 90 in your head to work out how many millimetres it is. So this is sort of saying 27 to 54 mils less than the average, so a drier forecast. But the critical thing is not to get hung up on that, how many millimetres is it saying? Is that the difference between me putting a crop in or not? It's not good enough to do that. This is another way. This is the ECMWF's way of doing it. And so there's a 100 to 50 millimetres. They've actually given you the aggregate. You're going to have to multiply it by 90. They're just saying that's 100 to 50 millimetres less than normal when you're that colour. So that's relatively easy to look at. But as I said there, don't get too hung up on the numbers and go for the vibe about whether things are looking wetter or they're looking drier. Rightio. So here's a map of, this is my Fastbreak analysis of lots of different models for spring 2015 and done in August. And you can see across the board there, every model's predicting an El Nino. So an incredible consensus of the models that they reckon that was going to happen. But in terms of rainfall, half the models have got drier tendencies there and the rest of them were sitting on average. And then as we know, what turned out was it was particularly dry over the southern parts. Match that up for 2016, completely different season, chance of a La Nina perhaps, but every model's saying negative IOD. Half the models once again going wetter for spring, half on average, and as we know, it turned out to be quite wet. So consensus, we think, is much better than just going and picking one model and hoping it's right. The models have skill, but you need to know what time of the year to be looking at them. You know, it's a bit like Kenny Rogers, you know when to hold them and when to fold them. And they have poor skill at some times and not in others, and location does matter. So I've got my picture of Dennis Denuto. I had to learn how to spell Denuto right, but to get it up. But it is the vibe. It is about what is a number of things saying here over rather than just picking my favourite model and hoping it gets it right this year. And as Graham said, if you'd like to do this for your state or region, we'd be happy to train you and help you out. Thank you.